In this lesson, we're going to take a look at graphing logarithmic functions. So as an example, generic form we have right here, f of x equals a times the log base b of x minus h plus k. And there's a couple key features that help guide us in graphing logarithmic functions. And that first piece is what is called the vertical asymptote. The vertical asymptote we get from our value of h. The h is the value that's being added or subtracted inside of the logarithm. Now, notice that it's a minus h, which clues us into that we always have to think opposite, because if a 3 is there, it's actually not negative 3. H is 3 because the negative is already present. Okay? So let's focus on that first in graphing before we start talking about the domain and range. So let's take a look at our first example. Here's how that vertical asymptote piece works. We recall from exponential equations that when we graph them, there's this horizontal boundary called the horizontal asymptote that we never cross over. Something like this. We could have a horizontal boundary, and we know that our graph levels off and never goes below that horizontal axis, so horizontal asymptote. The same thing is true with logarithmic functions, but because logarithmic functions are inverses of exponentials, it is not a horizontal asymptote, it's a vertical asymptote. The vertical asymptote, again, is at the location of h. For us, that is this location here, but remember, we have to think opposite. So because it's a plus 3, it's actually minus 3. So at x equals negative 3, I can draw a vertical line, okay, and label it as x equals negative 3. And I know that that's the boundary for my equation. My equation only works, or only exists, I should say, on the right-hand side of that vertical asymptote. Why? Because if I plug in any x value less than that point, say negative 10, if I were to plug negative 10 in here, I know that I would end up with a negative in the logarithm. And in the previous lesson, we saw that taking the log of a negative number is not possible if the base value is also positive. So we can only now, when we build our t-table, I'm going to build a t-table, I'm only going to pick x values larger than my vertical asymptote. I'm going to pick the x value right next to it. So that's going to be a negative 2. And then maybe to just stretch things out, I'll pick 3 and 7, just because I've got all the way up to 10 here to work with on my graph. So I can see my graph kind of stretched out and where it goes and what it looks like from there. So I need to get my calculator out for this. Okay, so there we go. I need to plug negative 2 in first. So if I plug negative 2 into my function up here, negative 2 plus 3 is 1. So what I'm going to do is I'm going to do the log of 1, comma, base value of 3. Okay. I'm going to close that parenthesis off, and then you'll notice I have to add 2 to my whatever that logarithm equals. So I'm going to do plus 2, and I can do it all in one step. So I'm taking the log of 1 with a base value of 3, then I'm adding 2 to it. And I end up with the value, y value of 2. Okay. Well, now I've got a 3 to deal with. I got to plug 3 in here. Well, plugging 3 in for x, 3 plus 3 is 6. So I'm taking the log of 6, comma, with a base value of 3 still, close that off, and now I'm going to add 2. End up with 3.63 as my y value. Now I'm going to do 7. 7 plus 3 is 10. So I'm taking the log of 10, comma, base value of 3, closing that off, and then I'm adding 2 to it. I end up with essentially 4.1. 4.1. So let's go ahead and plop these points now. Negative 2, 2. It's right here. 3, 3.63 is about right here. 7, 4.1 is about right here. Okay? Now, the way our function behaves is that it tails off down along our vertical asymptote and then arcs its way out through these points. Okay? In other words, it looks almost like an exponential equation tipped on its side, or rotated, I should say. Okay? And there's the graph of our logarithmic function. And there's a few things we want to answer about our logarithmic function. First thing is the domain. Well, the domain is all of the x values that we're using up. Now notice that I don't use up any x values less than my horizontal asymptote. Okay? Therefore, the only x's I'm using up are greater than my horizontal asymptote of -3. So my domain is all x's greater than -3. Now it's not greater than or equal to because my graph never actually touches -3. It levels off at -3. So there's no equal sign. Range. Range is the y values. Well, looking at this, there is no boundary in the vertical direction of what values my graph can reach. They can reach all values. Therefore, the range of my function is all real numbers. We use the R that looks like the money sign to represent all real numbers. Last thing we want to find in our equation is the x-intercept. So in our equation, the x-intercept is the location at which our graph crosses the x-axis. For us, it's that point right there. The question is, what is the coordinate of that point? Now, you may recall that in order to find the x-intercept, you plug 0 in for y. Well, the f of x here is our y, so we plug 0 in for that. So 0 equals the log base 3 of x plus 3 plus 2. Now, we actually have not looked yet in the sequence of what we're doing. We haven't looked at how to solve a logarithmic equation. Okay? So this is something where we have left it. We left it in class as the question to answer the following day when we learned how to solve logarithmic equations. What I'm going to do is I'm going to solve it right now. You're then going to have to go watch the next video to understand what I just did, and then come back and you can watch this again to see where I'm getting what I'm getting. So I'm going to solve this logarithmic equation for x to find my x-intercept. To do that, I'm going to subtract 2 from both sides. So I get -2 is equal to the log base 3 of x plus 3. I'm then going to convert from log form to exponential form. That gives me x plus 3 is equal to 3 to the -2. Okay. Well, 3 to the -2 is approximately 0.11. It's 0.11 repeating. Okay. So now last step, I'm going to subtract 3 from this. And I end up with x is equal to approximately -2.89. So that is the x value right up here that my graph crosses the x-axis. And I plugged y equals 0 in to get it. So the coordinate point is -2.89, 0. So the x-intercept, -2.89, 0. Now in some of the graphs, the graph will end up looking something like this underneath the x-axis. Sooner or later, as it goes out, it'll finally reach that x-axis, but it's going to happen way out there. So what you can do is, even though it's nowhere on the graph that you see the x-intercept, what you can still do is go through this process right here to find it and then just record the coordinate point as what the x-intercept is. So key features again of graphing a logarithmic function. Number 1, you have the vertical asymptote that drives everything. Okay? It's at the value of h, but again, you have to think opposite. Second, I constructed a t-table only using x values larger than my vertical asymptote. I then found my domain and range from that, and then my x-intercept.